Hello everyone, my name is Hongzhao Guan, a PhD student at Georgia Tech. My advisor is Professor Pascal Van Hendrik. Today I'm going to present ODMTS optimization in San Francisco. So one of the greatest challenges faced by most of the transit system is the first mile and the last mile problem. In this project, we try to address this problem using ODMTS. So the key part of ODMTS is to use on-demand shuttles. I can give you an example using the picture on the left. Suppose you start your trip from the origin. There will be a shuttle waiting for you in front of the door, pick you up, deliver you to a nearby train station or bus stop. Then you spend most of your travel time on the trains or the buses. After you get off the buses, there will be another shuttle waiting for you, picks you up and deliver you to the exact destination. So by doing this, the riders do not need to walk their first mile or last mile anymore. So in the ODMTS, we have multiple trains and multiple high-frequency buses. Most of them are adopted from existing transit lines. And we are also trying to design a few new bus lines using our optimization model. Continue from the previous slide. If we adopt some lanes from the existing system, we call them backbone lanes in the ODMTS. So using San Francisco as an example, we have three different sources. First, there are Muni Light Rail, represented by the blue lines. We have multiple high-frequency buses, represented by the red lines. And the yellow line represents the BART system in San Francisco. So all of these backbone lanes provide high-frequency and high-quality services to the riders. And the shuttles are usually treated as feeders to the backbone lanes. If we want to actually test an ODMTS, we need to set up hubs and stops. Let me introduce hubs first. All the transfers happen at hubs. You transfer from a shuttle to a bus, you transfer between two buses, you transfer from a train to a shuttle. They all happen at hubs. In the city of San Francisco, we have more than 500 ODMTS hubs. Most of them are just backbone stops. And we can add a few new hubs in some particular areas, such as underserved area or transit desert. For example, as I circle out on the picture, I added a few new hubs in the Twin Peaks area. So we can design several connecting bus lines just to make the whole system smoother for that area. The picture on the right shows all the ODMTS stops. The shuttles are operating at the stops level, which means they pick up passengers, they drop off passengers at the stops. The granularity of the stops is very high. In the city of San Francisco, we have almost 5,000 stops there. They are usually selected from residential areas and work zones. So with this high granularity, the ODMTS can provide riders door-to-door services. Now let's talk about the demand in San Francisco. The heat map in this slide shows the origins and the destinations. Currently, we work with trips inside the city of San Francisco, and we focus on a particular time period, 7 a.m. to 9 a.m. That is the morning peak. And it is the most challenging time period of a day. We also focus on commuters and transit users at this moment. Together, we have a large-scale problems with more than 40,000 riders in the system. From the heat map, you can tell the trips start from almost everywhere in the city, but most of them go to the downtown area because that's where all the job centers located. Here is a brief visualization for an ODMTS. The white lanes represent the backbone trains, backbone buses, and you see there are a few additional lanes that are newly designed by the optimization model. When I start to play the video, you can see many blue dots moving inside the cities. They are the on-demand shuttles, and most of them are used to serve the first mile and the last mile. There are also a lot of pink dots moving slower in the system. These are people who are working in the system. They work because they are already really close to a train station or bus stops, so we don't need to assign any on-demand shuttles for them. Here are some preliminary statistics. On average, we can save about 8 minutes for every rider. The agency can save about 10 cents on average while serving a person. These results indicate the ODMTS is beneficial from both perspectives. Thank you so much for listening. Now I'm open to questions.